In a previous video, I showed you that the exponential graph takes a general form like this, where a has a value and b has a value. Here is a very special type of exponential equation. If I say to you this a is equal to 1, and then that b is represented by the letter e. Now, e is an Euler's number, which I looked at in a previous video. It's approximately equal to 2.718. That's the approximation. It's similar to pi. So I'm representing b with the letter e, where e is 2.718. And here it is. Right, you're probably thinking, well, where's the 1 gone? Where's the 1 gone? Well, in algebra, you know, you don't need to put the 1 in front of the letter, so you can just leave that out. So that's what it is. Now, what's special about this is that when you want to find, for example, the gradient, let's say we want to find the gradient 2 along the corridor over here, 2 along the corridor, and how many up the stairs is it? Let's just flip that, just work that one out. So we have e is 2.718 to the power of, well, x is 2, isn't it? Right, we want to find the gradient at that particular coordinate. So what we do is, you don't need to work out the height of that triangle and the base of the triangle. That's not needed. I can tell you straight away that the gradient, the steepness of that line, is exactly the same as its y value, that one there. Right? So by finding the y value, the y coordinate, that is the gradient at that particular point. Right? So if I wanted to work out the gradient at, let's say, 3 along the corridor, just work at the y value, and the gradient at that particular point is also, it also takes the same value as the y coordinate. So when 3 along the corridor, 20 up the stairs, 20 and a bit, but I can tell you the gradient, the steepness, you see it's a lot steeper now, that line there, at that particular point. The gradient also happens to be 20.08. One more thing that you need to know is this. If I want to know the area, let's say back to this coordinate now, 2 along the corridor, if I want to work out the area under the graph of everything this way, all the way to minus infinity, everything on the left hand side of 2, the area under that graph also happens to be 7.38. And likewise, if I want to work out the area under the graph, everything on the left hand side of 3, so it's all of that, all the way to minus infinity, the area under the graph would also happen to be whatever the y value is. So that's what's special about this particular equation. But if it's any other type of exponential equation other than this, if it's something like this, and I want to work out, let's say, the gradient at that particular point, how steep that curve is at that particular point, then you do not assume that the gradient is going to be 12, same as a y value. That only works for this, and same goes for the area as well. Everything beyond, right? Do not assume the area, everything on the left hand side of this point here is going to be 12, right? That only works for this type of equation.